We're given the function f of x equals negative natural log of x. First, we're asked to find the domain of this function. Since it's a logarithmic function, we know that the argument has to be greater than 0. So we'll just set our argument of x greater than 0. So that gives us a domain of 0 to infinity. In order to graph this function, we're going to base it off of its parent function. So if we ignore this negative sign here, we can see that our parent function is just plain natural log of x. So we've multiplied a -1 outside of the grouping symbol, and the grouping symbol, if you can look at it as the argument, so nothing's happening to the argument, it's just a plain x. So this negative is on the outside, so that's a vertical change, so we're multiplying by -1 outside the grouping symbol, so we know that's going to cause a vertical reflection about the x-axis. So once we have the key points on our parent function, we're just going to multiply all those y values by -1. So let's make our table here, our parent function, natural log of x, and then our new function, negative natural log x. So our key points, remember we can't just use 0, 1, and -1 for logarithmic functions because we can't take log of 0 and we can't take log of -1. We have to take log of values greater than 0. So we can use 1. So log of 1, remember, is always 0. Then we use the base. If it's natural log, we know the base is e, so one of our key points is e. So natural log of e, the power of e that gives us e is 1. And then our third key point is the reciprocal of the base, 1 over e in this case. So if we take the natural log of 1 over e, the power of e that would give us the reciprocal of e, 1 over e, is -1. And we know our parent logarithmic function has a vertical asymptote at x equals 0. So now we're going to multiply all the y values here by -1 to cause that reflection about the x-axis. So I'll leave the x values the same, so this will be 1, and then 0 times -1, it's still 0. That'll stay the same. Then we'll have e -1, and 1 over e positive 1. And again, that vertical asymptote's not going to change. We didn't have any horizontal changes. So it will remain x equals 0. So we'll sketch our axes here, and remember that e is approximately 2.7, and 1 over e is approximately 0.4, and you can check those in your calculator and verify those in the calculator. So when we go to sketch this, on the x-axis we need to go to at least about 3, and on the y-axis we need to go from -1 to +1. So we'll make a little sketch here. So we want to go 1, 2, 3 at least on the x. And on the y-axis we just need to go -1 to 1. I'll do a few extra units since I marked them here. So we'll first label that asymptote, that vertical asymptote on the y-axis at x equals 0. So there's our boundary line. Our ramp has to approach that boundary line. So we'll first plot 1, 0. And then we want e -1, so about 2.7, -1. So we can label these here, 1, 0, e -1. And then we've got 1 over e, 1. And remember, 1 over e is about 0.4, so we'll go about halfway over and then up 1. So there's our 1 over e, 1. And we can see that ramp shape. It certainly does approach that vertical asymptote. We'll just get this approximate ramp shape. Okay, now from the graph, we want to determine the range of this function. So we can see that it certainly goes all the way down to -infinity and all the way up to +infinity, approaching that vertical asymptote. So we've got our domain, or excuse me, our range, negative infinity to infinity. Now, part D, we want to find the inverse of f. We want to find f inverse. So we'll first write our original function in a y equals form, so y equals negative natural log of x. We switch those x and y values to get our inverse, so we'll have x equals negative natural log of y. Now we need to rewrite this so the y is isolated. So we've got to get this y out of the argument of this logarithm. But before we can isolate the y, we've got to isolate the natural log of y. So we're going to have to divide both sides by -1. So we'll have negative x equals natural log of y. Now we can rewrite this in the equivalent exponential form using the definition of a logarithm. So we know the base of a natural log is e. So the base of our log is e. So the base of our exponent will also be e. And remember, the logarithm is always equal to the exponent, so it's equal to negative x, and then we set that equal to y, our argument. So then finally we'll use our inverse notation, f inverse of x equals e to the negative x. So remember, we started with a logarithmic function, and its inverse is an exponential function. Part E, we want to find the domain and range of the inverse function. So remember, the domain of the inverse will be equal to the range of the original function, which we found down here, is negative infinity to infinity. And then the range of our inverse will be equal to the domain of our original function, which we determined is 0 to infinity. Now we want to graph our inverse function. So in order to graph our inverse, we already have key points and the actual graph of the original function, so we'll just switch the domain and range, switch the x and y values to get the corresponding points on our inverse function. So on our original function, we have the key point, we had the key point 1, 0, so it's going to switch to 0, 1. And we have the point e negative 1, and it's going to switch to negative 1e. And then we had 1 over e, 1, and that's going to become 1 over e. And we had a vertical asymptote at x equals 0. So now we're going to have a horizontal asymptote. So we had vertical asymptote at x equals 0, and that will become a horizontal asymptote at y equals 0. And again, to approximate, remember our e, we can approximate that about 2.7, and 1 over e approximately 0.4. So we'll go ahead and sketch our axes here. So on the y-axis, we've got to go to at least 2.7. And on the x-axis, we've got to go from negative 1 to 1. Again, not very far here. So let's start by sketching that horizontal asymptote, that boundary line at y equals 0. So on the x-axis, and now we've got our key points. So we have 0, 1, 1, 1 over e. So remember, that's about 0.4. And then we've got the point negative 1e, so negative 1 and then approximately 2.7. So we can connect with that ramp shape. So we've got that decreasing ramp shape, and it's approaching that horizontal asymptote.